Welcome to Inside Builder channel. Understanding the building blocks of flow in CrewAI. How the execution of agents is controlled by flow. We'll be looking at that in this video. Here are some of the example flows that you are seeing. You might be wondering, this looks like rectangular boxes with names inside that. It is containing first method, second method, etc. The objective or the primary role of a flow is to move from one method to another method inside a class. It actually moves based on the earlier method's output. The purpose here, as it says, it's a flow of events. It's a flow of actions that is performed, and in each action, a part of the problem is solved. Here, there are three different examples of flows. One, this second part is having a router in the middle where it routes to two different routes. And then we have the third one, which is having the and or logic in this. We'll be seeing the code for all of these implementations. In the earlier videos, I had discussed about the flow with the intention of building an agent flow which writes the output of the LLM to a file. At that moment, I had only given the overview of the parts of this flow, like the and or logic or the decorators. The state, there are two different states, structured and unstructured states. The router start and listen decorators. We had not even touched what these decorators are doing in the earlier videos. In this video, we will be diving into the details of it. The methods are the center point of flows. The activities or the logic is built into the methods. The crews are also built into the methods, meaning the crews are kept inside the methods and they are called. The flow is a simple Python code that moves the execution from one method to the next, as I already explained. Decorators on methods control the execution of the entire flow. The router, start and listen, these decorators primarily control the flow. The state acts as a cache or a temporary database between all the methods inside the flow. The listening decorator helps to receive the data from the source method. Listening decorator, this decorator that you see here, it helps to receive the data from the source method. The terms and the ideas that are shared are very important. Once you see it in action, it will make sense. Next, there are two different states. One is the unstructured state, which is very flexible, but it can throw unexpected errors, and it can be difficult to find what are the keys that are present inside the state, because it is simply a Python dictionary. While the structured state is a Pydantic model, it is rigid. It is already defined. It has a defined set of input attributes. However, you can easily use the IDE's inbuilt completion options and the language server protocols completion options to get what are the attributes. So it's very user friendly. It has a good type safety. You cannot assign something to that particular state's attribute. if it is not matching the type. As I told you, these two are different states that you can use in flow. Let's now move into the code and see some action. Initially, we are going to look at a very simple structured state flow. You will see that there is a simple import that is happening here. And if you review the entire file or the code, you will realize that there is no agents, tasks, even LLMs. This might surprise you. You might wonder how come Flow is part of CrewAI, a framework that is agentic, which brings out agents, which helps us create agents, create tasks that do wonderful things with large language models, but there are no agents or tasks in this code. The idea behind this video is to show you the power of only the flows. The flow is like a conveyor belt. It actually moves the execution control from one method to another. I want you guys to see that in action. In order to see that in action, we are going to need a starting point, and that starting point is provided by the state here. In this case, it's a structured state, and the starting point of the flow is the flow's kickoff, which is going to take a dictionary value as the input. Across CrewAI, you will find that this dictionary input is pretty common. There is a reason for it. Much of the ecosystem inside CrewAI is managed with help of Pydantic, and it is almost all of the activities that is happening inside the framework with the agents, with the tasks, you name it, is all done with help of text. And it is done with help of simple, albeit very complex, simple and very user-friendly and understandable primitives, Python primitives. So flow is something that you have to understand inside out. We will now dive into the structured flow, and then I will also dive into the unstructured flow. Then we will move into the logic of AND, OR, and the router in the next video. What I'm going to do is I'm going to just execute this code, and then I'm going to show you how the execution works. So this is LunarVim, and you can see the execution on the side here. I'm going to move into cruise flow and building flows. That is where the files are located. So this is where I have the structured flow.py. You can see that file in this location, right? I'm going to execute this file. So the moment I execute this file, it's going to take a couple of seconds because it's going to load the modules and it's going to compile and then execute the flow. And it will error out. This particular flow will error out because I have made intentionally some mistakes. I will explain the mistakes after the error completes. So you can see that it has errored out, as I already told, and it is having a lot of information. It is talking about add edges, it is talking about nodes, it's talking about net, it's talking about visualizer.plot. It all screams that there is some kind of a tree data structure that is built underneath the flow, and that is how the flow is working. The CrewAI flow is almost close to the finite state missions data structure, which finite state mission actually stores the events and the states. Here structured flow or the CrewAI flow is also storing the state and providing the ability to save the events. The reason why the flow failed is because the listen method is listening to the wrong method. So it has to listen to the correct method. The correct method in this case is the first method. So if you look at the code here, you will see that the structured flow class is declared or defined, and it is inheriting the flow class from the flow module inside CrewAI, and also it is inheriting the example state from the class that is defined here, which is a Pydantic model. If you are uncomfortable with the inheritance, if you are not familiar with Pydantic, it's actually not required to, it's not a prerequisite that you need to understand these things. It will be beneficial that if you know the purpose of how these concepts work in Python, but it's not a prerequisite. Most of the things you can clearly see how it works, and then you can just remember it and then move forward. Later you can learn it. If you have time, take a look at Pydantic and try to understand it for a better and faster understanding of the code. It's anyway going to help you. The first method here is incrementing the counter. So there is a counter attribute for the state, and we have declared or defined the counter and the message attribute for the state. That is how we are able to use the dot operator for this state. So we are incrementing it in the first method, and in the second method, which is having a decorator called listen to first method, is literally going to take the return value, this entire value that you see on line number 14 will be returned, the string will be returned through this method, through this parameter, I'm sorry, first meth op. So through this parameter, that value will be returned, and the value first meth op is used inside the second method to set the state.message value. By default, the state.message has been assigned an empty string. This is mandatory because when you are going to initiate the flow, you need to have to give the value to the state based on the variables or attributes that you have already defined for that state. If not, it will throw an error. So in order to avoid that error, it is always better to give a default value. I will be showing you the example how it is helpful. Now that we have assigned the value by using the plus equal to symbol, so here we are basically concatenating the empty message with the string, the string, and then finally we are returning the state. So here we are instantiating the flow, structured flow, and then we are plotting it. So this will plot the plot that you saw in this place, so it will plot that. So these plots are plotted by this plot method, and then comes the kickoff. So the kickoff is where you are going to give the value to the state, and it is going to take it and proceed further one method at a time. And then you can print the flow output also. The flow output will contain the last return value of the flow. So let us actually look at the output right now. Let me go into crew flows, building flows, and here I am going to start the flow. Python structure flow.py, and this time the code will execute, and you will also see the output of the state going through. Next, you can see that it has executed, the plot has been saved. Let me show you the plot so that you will understand what's happening. So I'll be using the xdg open. It's a Linux application that opens the file with its compatible app. Structure. So in case of png.html, the compatible app is a browser. So that's where it will open, and you can see that the first method goes to the second method, and you can see lots of other things at the bottom. So the double slash is and, the straight line is trigger, and the router has a red color to that. Fine. So you have the start method as red. CrewAI has done a wonderful job in creating a good, in fact, very presentable interface, presentable output for the flows. Let's now go back. You can close this, you don't need that. I'm going to do a CLS. Now what I'm going to do is, in case if I don't give any value, right? If I don't give any value to the structured flow, the flow will still execute. So let me show you. The flow will still execute, excuse me. The flow will still execute because the state has got a existing default value. So because of that, the flow will not error out. But the same will not be true. As you saw here, the flow still executed. The result of the second method, first method is 2. If you go back here, Kickoff kicked the flow into action. The state is set or defined with counter at 0 and message at empty message. Here the state gets incremented by 2, which is then again sent as a return statement to the second method, where the second method is taking that first method op and then concatenating it with result of second method string and then providing the output. So that's what's happening. This is a very different way of looking at programming, but this is how most of the complex systems, frameworks are developed at the back end. It is always important to understand these kinds of innovative data structures. FSM is one such data structure. I wouldn't say it's a data structure. It's a finite state machine. It's actually a machine that actually moves the things. It executes in literal sense of a program. It itself acts as a program. So it's a vast subject. It's one of the most difficult subject in computer science. That's what I've heard. But it is made really simple by the CrewAI team. In the next discussion, I will be diving into the unstructured state and also the rest of the decorators. So let us go back. We have covered the basics of flow. We have covered how the methods execute. We have seen the parts of the flow and also the structured state, how it is useful. So we have seen that. I believe that this video provides you a very good introduction into the flow states as well as how the flow is operating. In the next video, we will dive into the complete detail of the rest of the flow methods. With that said, I would like to take the leave. Practice, 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 practice. See you guys. Have a great time.